Hello and welcome to this video where I'm going to be going over the sample assessment for the Edexcel IGCSE in Maths. Now, this is for the Unit 1 paper for the modular pathway. So this is the new pathway where you sit 2 papers, Unit 1, which will be at the end of the first year of your course, and then Unit 2 at the end of this second. And this is the higher tier paper. Because this course is new, there are quite few resources for students to work from. We only have this sample paper available. I have made some more sample papers myself, which I created looking at the content for the course and taking past questions from the linear IGCSE. And you can download those sample papers completely for free, and I will put some links in the description for you. Now I'm going to go through question by question. If you have already tried this paper and there's one particular question you want to look at, then obviously feel free to fast forward the video until you get to that point, and I'll go as quickly as I can so it's not too long. So in this first question, we are told that we have the weight of a cake. It's been rounded to 2 decimal places, and we have been asked to work out the lower bound for the weight. Now I usually find it easiest to start off with upper bound. It's been rounded to 2 decimal places, and so I can just put a 5 on the end like that, and this will give me the upper bound. And then for the lower bound, we are going to subtract 5. So instead of having 5, 5 on the end, I want 4, 5. Lower bound. And it's the lower bound the question asks for, so this will be my answer. Right, on to the next question. So this is a show that question, which means that we do not just want to use our calculator, we need to show step by step how we would solve this. So first of all, I need to take them from mixed numbers to improper fractions. So I'm going to do 5 times 3, which is 15, plus the 1 is 16 over 3, minus, and then 2 times 7 is 14, plus 6 is 20 over 7. Now, I can't subtract these fractions because the denominators are not the same. I'm going to take this fraction here and multiply by 7. I'm going to take this fraction here and multiply by 3, and then they will both be over 21. So 7 times 16 is 112, 3 times 7 is 21, and then 20 times 3 is 60, and 7 times 3 is also 21. Now we have a common denominator. I can subtract these. 112 minus 60 is 52. And this is over 21. Now, once you've got this into an improper fraction, we now want it as a mixed number. And you can check this on your calculator, or you can see how many times does 21 go into 52. Well, that will go twice, because 2 times 21 is going to be 42. And then how much do I have left over? I have left over 10. 52 minus 42 is 10, and that is over 21. The denominator remains the same. And that's all the steps you need to show to get your marks. Moving on to the next question. So here we have a spinner. We have the probabilities that the spinner will spin once. It will land on 1 or it will land on 3. 2 and 4 are missing. But I get this piece of information here. The probability that the spinner will land on 2 is equal to the probability that the spinner will land on 4. So I don't know what it is, but I would use some algebra. So I'm going to call both of these x. I can call them both x because they are equal, they're the same. Now, Priya is going to spin the spinner 250 times, work out an estimate that will land on 1 or on 2. I'm going to need to find this x first, so let's do that. So I know all these probabilities add to 1. So I have 0.26, 0.26 plus 0.18 plus, now I have 2x is equal to 1. And now I'm solving this equation. So I'm going to do 1 and I'm going to subtract 0.26 and I subtract 0.18. And so I have 2x is equal to 0.56. And now I can divide through by 2. So x is 0.28. And so these are the values here, 0.28 and also 0.28. Now, we haven't actually got the answer for the question because we want an estimate of the number of times the spinner lands on 1 or on 2. So I'm going to add together the probabilities for 1 and 2, 0.26 plus 0.28, and this is 0.54. So this is the probability that I land on either 1 or 2. Priya spins 250 times, so I'm going to do 250 multiplied by that probability to work out how many times the spinner will land on either of those two, and this is 135. So that's my answer, 135. Okay, moving on to the next question. This is an expansion. So here you could use foil, you could use a grid, or you could use these smiley faces. Either way, you're going to multiply everything on the left hand by everything on the right hand bracket. So n times n is n squared, minus 6 times n is minus 6n, 4 times n is plus 4n, and then lastly, minus 6 times minus 4 is negative 24. Now I can collect together the 6 and the 4n, and I'll have n squared, minus 6 plus 4 is negative 2n, minus 24. Okay, on to the next question. We are solving here, so I see I have a fraction. My first job is to try and get rid of that 4 in the denominator. And this is a division, the opposite of division multiplication. So I'm going to multiply everything up by 4. So this is going to be 4 times 2x minus 3 is equal to 3x minus 5. Now I need to expand that bracket there. So I have 8x minus 4 times 3, which is 12, is equal to 3x minus 5. Now, I have x's on both sides. I want to get all the x's on one side, so I'm going to subtract 3x. So 8x minus 3x is 5x minus 12 is equal to negative 5. And then lastly, I'm now going to take that 12 onto the other side. I'm going to add 12. So I have 5x is equal to 5 plus 12, negative 5, sorry, plus 12, which is 7. And then I can divide through by 5 to work out x is 7 over 5. And if you wrote that as a decimal, it's also fine. So as a decimal, it would be 1.4, and that's no problem at all. Okay, question 5, we have a plane. The plane is traveling 3,980 kilometers in 5 hours, 24 minutes, and we're looking for average speed. So speed is distance over time. You might write it like a triangle like this or like this. Speed is distance divided by time. So the distance is going to be 3980. The time is a little bit tricky. So I have 5 hours, 24 minutes. This is not 5.24. We need to change these 24 minutes into a fraction of an hour. And to do that, I'm going to divide by 60. 24 divided by 60. And that is 0.4. So 24 minutes is 0.4 of an hour. And so we have 5 hours and 24 minutes, so 5.4 hours. This 24 minutes is the 0.4 part. So we're doing 3,980 divided by 5.4, and that is 737 kilometers per hour. On to the next question. So here we have a shape, and we are asked to work out CD. So that's this length here. CD, and I know the area of the shape. The area of the shape is 434 centimeters squared. So I'm going to split this shape up into two parts, and I am going to split them up like this. So first of all, this rectangle at the bottom is going to be 28 times 12. That's the area of the rectangle. And that is 336. So I know the total area is going to be the area of the rectangle, and I need to add on the area of this trapezium at the top. And the formula for area of a trapezium, which you have on the formula sheet, if you scroll up to the top, you will see, is a half a plus b times h. So I have a half times a plus b times h, and I need to work out what these values are. So for the a value, that is the distance across the base here. And I can see that the whole way across must be 28. And then each of these little side parts are 5. So 28 minus 5 is going to leave me with 18. So this base here is 18. So one of these will be 18. Now the top of the trapezium, I don't know. I'm going to call that CD. That's the thing we are looking for. And the height, I think I can also work out, because I know that the total height is 20, top to bottom, and then the height of the rectangle is 12. So if I do 20 minus 12, I get 8. So therefore the height of this bit here is 8, multiplied by 8. So that is the formula for the area of that trapezium. And I know when I add that to the area of the rectangle, I need to get this total 434. So let's add that. So the rectangle is 336 plus the trapezium, which is a half 18 plus CD all multiplied by 8 is equal to 434. Now this is algebra for us to solve, so we take the 434 and I'm going to subtract the area of the rectangle to work out what the area of the trapezium must be, and that will be 98. So I have a half 18 plus CD multiplied by 8 is 98. And then now we need to do some algebra here. So what we are going to do is we're going to take 98 and divide by 8. And I get 12.25. And then I have a half here, so multiplying by a half, I now need to take the 12.25 and divide by a half, or that's the same as multiplying by 2. And you will get 24.5. So I have 18 plus CD is 24.5. And so we are very close. All I'm now going to do is subtract 18 to have the length of CD, which is 6.5. And we're done. Okay, on to the next question. So simplifying. Whenever you raise anything to the power of 0, this is 1. So this question here is just 8 times 1, which is 8. And then here, when you are dividing with indices, you're going to subtract the indices. So this is going to be x to the power of 6 minus 5. I need to subtract. So this becomes a minus. I'm going to subtract 6 minus 5, which is 6 plus 5, which is 11. So therefore, P is 11. On the next question, we're going to raise everything to the power of 3. 2 to the power of 3 is 8. K squared to the power of 3 is k to the 6. You multiply the 2 and the 3. And then m to the 4 to the 3 is going to be m to the 12. Again, you multiply the 4 by the 3. Question number 8, change the speed of 81 kilometers per hour to meters per second. Now, I would usually do this in 2 steps. So first of all, I'll change the kilometers to meters. And to do that, if I want to go meters per hour, you're going to go more meters in an hour than you would kilometers in an hour. So I'm going to times by 1,000. That's the number of meters that there are in a kilometer. And so this is 81,000. Now this is meters per hour, not meters per second. So now I'm going to try and change it into meters per second. Now usually to get from hours to seconds, you would actually multiply in this case by 60 and then by 60 again. But this is meters per hour. So if you think about how many meters you travel in an hour, comparison with how many meters you would travel in a second, you're actually going to go a lot further distance in 1 hour than you would in 1 second. This needs to get smaller because we're going to go less meters in a second than we would in an hour. So it's because the time is actually being divided here. So because it's per hour. So we're going to divide by 60 to get it into minutes, and then divide by 60 again to get it into seconds, or it's the same as just dividing straight through by 360. And we have a final answer of 22.5. Okay, on to the next question. So now here we're trying to simplify some indices again. First of all, you can do 3 times 4, which is 12. A to the 4 times A to the 7. So now we are going to add together those powers, and 4 plus 7 is 11. And then B to the 5 times B to the 2, you're going to add together those indices again, so it's B to the 7. Factorising. What can we divide 14 and 21 by? Well, I can divide them both by 7. So I'm going to take 7 outside the brackets. What can I divide x squared by and x cubed? The largest thing I can take out of there is x squared, so let's do that. And then I have y to the 4 and y squared. I can divide them both by y squared. 14 divided by 7 is going to be 2. X squared divided by x squared, well, that leaves just 1, it goes away. And then y to the 4 divided by y squared is y squared. Next term, we have 21 divided by 7, which is 3. x cubed divided by x squared is going to be x to the power of 1. And then y squared divided by y squared, that just goes. And so this is our final answer. Straight line, we need to find an equation for the line. Now straight away I'm seeing that the y-intercept is 4. So we have y is equal to mx plus c. And c is going to be 4. That's easy to spot. For the gradient, you're going to have to do rise over run, or change in y divided by change in x. And so find somewhere where the graph crosses the coordinate grid, like here and here, for instance. And I can see that the change in y, here we go down 2. So you must be careful. In this case, it is -2. And then along 1, and so that's 1. So this is going to be -2 over 1, or just -2. So y is -2x plus 4. Just be careful that this is negative, or you could do it like I did. So I said that we're going down 2. Or once you work out the gradient, you can just check if it's positive or negative. So anything with an upward slope is positive. Anything with a downward slope is negative. Positive gradient, negative gradient. Okay, now we have a different straight line. So let's not confuse this with the question above. And we were told the equation of that line. Write down the coordinates of the point crosses the y-axis. Well, it crosses the y-axis when x is 0. So I'm going to put x 0 in here. 3 times 0 is 0. So y is -5. And then we write this as a coordinate. First coordinate is x, which is 0. Then the y coordinate, which is -5. And we are done. Okay, question 14. So here we have some triangles. Our first thing we want to find out is the length AB. This is this length here. And this looks to me just like a Pythagoras question because we have a right angle triangle and I know 2 of the sides. So A squared is C squared. It's usually done like this, isn't it? A squared plus B squared. Where this is C, this is A, and this is B. So I actually have one of the shorter 2 sides, so it's going to be a subtraction. So I'm going to take 7.5 squared, and I'm going to minus the short side that I have, which is 6 all squared. And this gives me 20.25. But this here is actually A squared, sorry, B squared. This is B squared, not B. So I actually need to take the square root to get the final answer. I need to take the square root to get the final answer. And here we get 4.5. So B here is 4.5, and I can write that in on the line. Now the next question is to work out the length of AD. Let's go back and look at the shape. So AD is this distance here. And to get this, I'm going to have to use the fact that the area of the whole shape is 31.5. So I can work out the area of the triangle at the bottom because I just worked out that this side length here is 4.5. And the area of a triangle is a half times the base times the height. So I'm going to do a half times 4.5 times 6. And this is 13.5. That's the area of that triangle there at the bottom. And I know if I add that to this triangle, and this triangle here, this is the length that I want. What should I call this? We've used ABC. Let's call this D, this side length D. So I'm going to have 7.5 times a half times D times that side there, D. This is going to give me the area for this triangle here. And then when I add both of those together, I should get to this, the 31.5. So I am going to now form an equation. I'm going to say that the area of the triangle that we worked out, so that was 13.5, plus the one that we don't know, which is a half, times 7.5, times that length that I called D, is going to be equal to the total area that we have, which is 31.5. And then we can solve this equation. So first of all, I'm going to subtract 13.5, and so I have a half times 7.5 times D is equal to 18. And then I'm going to do 18 and divide by 7.5, and divide by a half, and I will look at the side length. D is 4.8, and we are done. Okay, here we have a tree diagram. So Tess has a bag containing 11 beads, 4 are red, 7 are blue. She takes one at random and she keeps it. And we need to fill in these branches here. So in this scenario, for these branches that we have missing, she has taken a blue bead already. So the blue counters must go down by 1. Also, the total in the bag will go down by 1. So in our world, we no longer have 11 counters. We actually have 10 counters in both cases. Sorry, 10. The red beads will remain the same. So I can see from the top here that we have 4 red beads, and the blue beads would have gone down by 1. So we did have 7, now we must have 6. And this is what our tree diagram should look like. Okay, then we're going to have to work some stuff out. Work out the probability both of the beads are red. This is just 4 over 11. The probability that she gets a red bead in the first case, multiplied by the probability she gets a red bead in the second case, so 3 over 10, and you get 6 over 55. Next question. Work out the probability that the 2 beads are of different colours. Let's go back and look at the tree. So different colours. So if she takes a red bead first, then she needs to take a blue bead second. So that's going to be 4 over 11 times 7 over 10, which is actually 14 over 55. And if she takes a blue bead first, then she needs to take the red bead second in order to have different colours. So that's 7 over 11 multiplied by 4 over 10, which is also 14 over 55. So we're just going to add these two things together. So if she takes red blue, we have a probability of 14 over 55. If she takes blue red, we also have a probability of 14 over 55. And then so the probability she takes 2 beads of different colours is going to be 28 over 55. Okay, so moving on to question 12. Here, this is difference of 2 squares. So I can see that this is a square number and this is a square number. And we have this rule. If we have x squared minus y squared, so 2 square numbers, we can factorize them like this: x plus y and x minus y. So this is what I'm going to do to this. Now I need to take the square root of 9x squared. And so this is going to be 3x. And then I'm going to do plus. I need to the square root of 4y squared. So that's 2y. So 3x plus 2y and also 3x minus 2y. Right, next question. Expressed as a single fraction in its simplest form. These denominators are not the same. So the 8 and the 4x are not equal. I need to get them both over the same denominator. I'm going to take this fraction on the left and I'm going to times it by x only. So this is going to be 7x over 8x. Now I'm going to take the fraction on the right and I'm going to multiply all this by 2. So this is going to be 2x plus 3 over 8x. And so you can see here, by multiplying this one by x and multiplying this one by 2, I have them both over 8x common denominator. So now I can do the subtraction. So I have 7x minus 2x plus 3 all over 8x. And then I want to simplify this. So to do that, I'm going to expand this bracket. So this is 7x minus 2x minus 6 all over 8x. And then I can collect together that 7x and the 2x. And so we have this as being 5x minus 6 over 8. Okay, moving on to the next question. So here we have an expansion question. We have 3 brackets to expand here. So you're going to ignore one of them. I'm going to ignore this one at the end and just expand. It's not really a smiley face. Just expand the 2 brackets on the left. But you could choose any 2 brackets to start off with. I'm going to expand these 2 here. So 3x times x is 3x squared. And then minus 1 times x is minus x. And then 2 times 3x is plus 6x. And lastly, minus 1 times 2 is negative 2. I can simplify this down. So this is 3x squared plus 5x minus 2. Now that's the expansion number. That's only for that first two brackets. Remember, all of this needs to be multiplied by 3x plus 1. All of this needs to be multiplied by 3x plus 1. So I'm going to go through and take this first bracket and multiply everything by 3x. And we get 9x cubed plus 15x squared minus 6x. And then now I can multiply everything by 1. So that's going to be plus 3x squared plus 5x minus 2. Once you've done that, it's a case of collecting together any like terms. So we only have one x cubed, and that's the 9x cubed. I can't collect with anything. I've got two squareds. I've got 15x squared plus 3x squared, so that's plus 18x squared. Two numbers in x, minus 6 plus 5, which is going to be minus x. And then the minus 2, again, is just by itself. And then, so this is the final answer. Do we have a dotted line? Yes. 9x to the 3 plus 18x squared minus x minus 2. Okay, simplifying. More indices. And just as a note, I did think this paper was very heavy in indices. There was about 3 or 4 different questions. Whether that was conscious on the part of Edexcel, I do not know, but I wouldn't expect there to be quite so many indice questions usually. I think we still have one more coming up as well. So this one here, we're going to simplify this. Now, this, we have a minus 2 up here. There's a few different ways that you could simplify this. So you could deal with what's inside the brackets first and then deal with the indice on the outside. I actually am going to, first of all, deal with the negative. So when you have anything, so for instance, let's say we have x to the power of minus 2, then this would be 1 over x squared. Now, also, if I have x over y to the power of, I don't know, minus 1, then the x is going on the bottom, the y is going on the top. It has the effect of doing this. It's the same thing. So whenever you have a negative indice, you're going to flip. All the stuff that is on the bottom is going to go onto the top, and all the stuff on the top is going to go onto the bottom. And so that's the first thing that I'm going to do to this fraction, is to get rid of that negative indice and reverse everything. So it's going to be 8xy squared over 2x to the 5. And then this now is not to the power of minus 2, but just the power of 2. Yeah, so that negative part just had the effect of flipping everything on the inside. Now, again, you could simplify or you could square first. It's up to you. I think I'm going to simplify. So 8 divided by 2 is 4. X divided by x to the 5. Wow, this is going to be x to the 4 on the bottom of the fraction. This x here will cancel down with just one of these. And then the y doesn't cancel with anything, so this is y squared. Now, this is all still being to the power of 2. So now it's a case of squaring everything. So 4 squared is going to be 16. Y to the power of 2 to the power of 2 is going to be y to the power of 4. Multiply the indices. And then x to the 4 to the 2 is x to the 8. Again, multiply the indices. Okay, let's move on to the next question. So this is question 100. We have 100 farmers. They have goats, sheep, or chickens. Now, for these kinds of Venn diagram questions, where you have a whole list of things, it's usually, or almost always, going to be easiest to start either outside the Venn diagram completely, so ones that do not have any, or right in the middle, ones that have all 3. So let's see what I have. I actually have this 20, do not have goat, sheep, or chicken. So I'm going to put 20 farmers on the outside, and we've actually already done that one. And then let's look for if we have all 3. Yes, we do. So 6 have goats, sheep, and chicken. So I'm going to put 6 in the center, and I've also dealt with this one here. Now I would build out. So what I'm going to do now is look at the ones that have goats and sheep. So who has goats and sheep? That's actually these 11 farmers. 11 farmers have sheep and goats. 6 of them already have all 3. So it's these parts here added together must add to 11. So we're actually going to do 11 minus 6 to see what's left. And so that's 5 that have sheep and goats, and do not have any chickens. So that's this one done. And then I do the same thing for sheep and chickens. So sheep and chickens is actually going to be these 2 sections, 6 and whatever that is, which I'm now going to work out. And this must add to sheep and chickens 17. So I'm going to do 17 minus 6. I've got 5. And then here's 17 minus 6 is going to get me 11. So that's an 11 in there. And then the last one is going to be 18 have goats and chicken. So we have 18 minus that 6 again is going to be 12. And so it's 12 that go in this category here. And this is also done. Now we need to fill in these 3. The farmers have only goats, only sheep, or only chicken. So 31 have sheep. So 31 farmers have sheep. Well, that's going to have to be all the farmers inside this bubble here. So I'm going to do 31 minus 5 minus 6 minus 11. And this is 9. So we have 9 that just have sheep. And then we have 53 that have chickens. So this bubble here, the chickens bubble, needs to add, sorry, I forgot that already, 53. This bubble here needs to add to 53. So that's the 12, the 6, the 11, and whatever this is, which I want to work out. So I'm going to do 53 minus 12 minus 11 minus 6. And you are left with 24. Now we have a problem here because I've actually used all the information. If you look back at the list, I've now used this also. I don't have any more information. However, right at the top, we were told that we had 100 farmers in total. So to work out how many farmers have goats only, I'm going to take the full 100 farmers and I'm going to subtract everything that I've worked out. So minus the 20, minus 5, minus 6, minus 12, minus 11, minus 9, and minus that 24. So I take everything in the diagram away from 100 to see what is left, and we have 13 left that only have goats. And that's the Venn diagram all filled in. Okay, now we have some questions. The number of farmers that have goats. So the number of farmers that have goats is going to be 13 plus 5 plus 6 plus 12. And that is 36. Now this is G union S dash. And so I'm looking at the union first, and then I want everything that is outside the union. So G union S is the 13, the 5, the 9, the 6, the 12, and the 11. That's the union of G and S, everything that is inside these two bubbles here. And then I actually want the complement, so all the things that is not in those. Well, the things not in those bubbles is just the 24 and the 20. So this is just 24 plus 20, which is 44. Right, moving on to the next problem. We want the number of things that are not in S and not in G, sorry, and also in C. So not in G and in C. All the things that are, let's rub out these bubbles. All the things that are not in G is going to be, this isn't in G, this is not, and this is not. And then we want to intersect that with the things that are in C. Well, the only things that are in C is this 24 and this 11. So this is going to be 24 plus 11. And that is 35. Of the farmers who have chicken, one of the farmers who has chicken is chosen at random. Find the probability this farmer also has goats. So on the bottom, what we want is we want the number of farmers that have chickens, because we know that they must have a chicken. And then on the top, we want the farmers who have chickens and have goats. This is called conditional probability. So let's look at the number of farmers that have chickens. Well, the number of farmers that have chickens is everything in this bubble here, which is going to be 53. And then out of those farmers that have chickens, which ones also have goats? Well, that is only going to be these farmers and these farmers. So the total that have chickens is 53. The ones that also have goats is 18. So this is going to be 18 over 53. Okay, moving on to question number 15. Martin and Lucia went on 2 different car journeys. We have some details for Martin's distance and time, Lucia's distance and time. And then Martin says, my average speed could have been greater than Lucia's. Show that Martin is correct. So these have all been rounded, correct to the nearest, correct to the nearest, correct to the nearest. This is actually a bounds question. What they want us to do is to work out the maximum possible speed that Martin could have been going. And then see if that is bigger than Lucia's average speed. And what we'll actually do is take the minimum of Lucia's average speed. And then we will see if the maximum possible that Martin could have been going is more than the minimum possible that Lucia could have been going, then actually he could have been going faster. The could is the key word there. So this is a bounds problem. You do get a mark for working out any of these bounds. So you could work out the upper or the lower bound for any of these values, and that will get you your first method mark just by doing a bound. I will just focus in on the ones that we want. So speed is distance over time. And if I want to work out a maximum speed, then what I want to do is I want the distance to be really big, and then I want to divide by something really small. So I want the upper bound of the distance and the lower bound of the time. If you take a big number and you divide by a small number, you'll end up with a big number. So the maximum bound for the distance, this has been rounded to the nearest 5. We need to take this 5 and divide it by 2. And then I'm going to add it on for maximum distance. So 5 divided by 2 is 2.5. Add that on to the 80. This is going to be 82.5. So the maximum distance is 82.5. And then we're going to divide by minimum time. This is correct to 1 decimal place. And so to create the lower bound, this is going to be 2.65. So I'm going to divide by the minimum for the time, 2.65. And that gets me 31.13. Now let's look at Lucia's, and we want to get her minimum to show that Martin could have been going faster. So to get her lower bound, we're actually going to take the smallest possible distance that she could be going, and then we want to divide by a number very big, so the largest possible time that she could have gone. So the minimum bound for this distance, this has been rounded to 2 significant figures. So upper bound would be 33.5, and the lower bound would be 32.5. That's the minimum bound for her distance. And now we're going to divide by the upper bound for her time. This has been rounded to the nearest 0.1 of an hour. Again, I will need to divide that by 2. This is to 1 decimal place. It's been rounded. Divide that by 2, you get 0.05, and that is what we are going to add on to the hours. So the upper bound for her time is 1.05. And when you do that division, we get 30.95. And you can see that 31.13 is bigger than 30.95. Therefore, Martin could have been going faster. Although that conclusion, I think, according to the mark scheme, I think it's unnecessary. Just come into those the upper bound and the lower bound for Martin and for Lucia. We'll do it for you. Okay, the histogram. So we have some information about the histogram. I'm told that there are no children where their time M, what is this? What have they been tested on? This is the taken to walk to school. This is the how long it takes each child to walk to school, and there are no children who take more than 100 minutes. All that is showing us that there's no bar there, so it's not really extra information for us. However, this one is interesting. There are 10 children for whom the minutes that they take is less than or equal to 20. So that's this first bar here. This must represent 10 children. Now in a bar chart, area is frequency and frequency is area. So what that means is that the area of this bar must be 10. Area equals frequency. And so if the area of the bar is 10, I know that this side here is 20. And so 20 divided by 10 is 0.5. So the height must be 0.5. That's the frequency density. Now this is the first point on our scale, which will help us create the rest of the scale. If that's 0.5, then this must be 1. This must be 2. This must be 3. This must be 4, and so on. But I think that's all I'm going to need. Work out an estimate for the number of children who were between 50 and 80 minutes. So where's 50? 40, 50 is here. Where is 80? 80 is here. And remember, I said that area is equal to frequency. So an estimate for the number of children between these times is exactly the same as working out the area of the graph between those two times. So what I want to do is to work out the area from here all the way up to here. And I will have the total area of the bars, which is the same as the frequency. So this distance here is going to be 10, because that is 50. 50 to 60 is 10. So I'm going to do 10 times the height of that bar, which is 2.9. And that gets me 29. Now I'm going to have to do this because all these bars are different heights, so I need to do it separately. The area of that bar there is 29. Now I'm going to go on and do this one in the middle. So this is between 60 and, well, that's going to be 70, and that is halfway along, so that is 75. So between 60 and 75, that is 15. So I'm going to do 15 times the height of the bar, which is 3.2 there. And that's 48. So the area of this bar here is 48. And then I need to do this little sliver here between 75 and 80. So between 75 and 80, that's a width of 5 times the height, which is 2 exactly. And so this is 10. So this has an area of 10, or a frequency also of 10. Then I'm going to add those three numbers together, 29 plus 48 plus 10, which gives me a total of 87. Okay, next question. Okay, so we have a third question here. This is another one where there are probably a few different ways around this. So you could straight away multiply by root 2 plus 1 squared over root 2 plus 1 squared. What I would actually tend to do is expand this out. I don't really like the squared thing on the bottom, so I'm going to expand that first. Root 2 minus 1 all squared. Let's just work out what this is. So root 2 times root 2 is going to be 2. And then I have minus 1 times root 2. Actually, probably I should note root 2 squared. Root 2 minus 1 squared is root 2 minus 1 times root 2 minus 1. So what I'm actually doing is this. So root 2 times root 2 is 2. Minus 1 times root 2 is minus root 2. Minus 1 times root 2 is minus root 2. And then lastly, minus 1 times minus 1 is plus 1. And so then we can simplify this. 2 plus 1 is 3. Minus root 2 is minus 2 root 2. So this is just the denominator simplified. I'm going to rewrite out this fraction again now with that simplified denominator. And actually, I'm going to rewrite the root 8 as well. I'm going to note here that the square root of 8 is the same as root 4 times root 2. We can split this up. 8 is 4 times 2. The square root of 4 is 2. So this is 2 root 2. So I'm going to rewrite the root 8, 3 plus root 8, as instead being 2 root 2. If you don't do that, you can still get to the same answer. It's fine. But I think it's just going to be easier to simplify it first rather than simplify it at the end. So this is 3 plus 2 root 2 over 3 minus 2 root 2. And we need to rationalize this. To rationalize, you take the denominator, whatever that sign is in the middle, you swap it. So we're going to multiply by 3 plus 2 root 2 over 3 plus 2 root 2. And now I'm going to expand this. So to multiply this, 3 times 3 is 9. And then I have 3 times 2 root 2, which is plus 6 root 2. And then also another 3 times 2 root 2, so another plus 6 root 2. And then this is a little bit hard. I have 2 root 2 times 2 root 2. Well, 2 times 2 is 4. And root 2 times root 2 is just 2. So this is 4 times 2. Or actually, I'm going to straight away write that in as 8. Over And now let's do the denominator. So 3 times 3 is 9 again. And then 3 times positive 2 root 2 is plus 6 root 2. And then 3 times negative 2 root 2 is going to be minus 6 root 2. And then lastly, I have a positive times a negative, which is a negative. And I have that same thing again, where 2 times 2 is 4. Root 2 times root 2 is 2. And so this is going to be 4 times 2, which is 8. Now let's simplify this a little bit. So I have 9 plus 8, which is going to be 17. 6 root 2 plus 6 root 2, which is plus 12 root 2. And then 9 minus 8, which is 1. And then these two things here will cancel. So this is 17 plus 12 root 2 all over 1. Well, the over 1 doesn't matter. That's just 17 plus 12 root 2. But if you look at the question, it's asked us in this form. P plus root q, where P and Q are integers. So the 17 is fine. That's P. This is not okay. This is not one number. So I'm going to rewrite 12 as being the square root of 144. Square root of 144 and 12 are the same thing. So you can square 12 and put it in a root, and it's exactly the same. You have two ways of writing the same number. And that has been multiplied by root 2. And now I do the opposite of kind of what I was doing in this process here. I'm working backwards. So 144 multiplied by 2 is 288. So this is 17 plus root 288. So quite a long question there. Right, let's move on. And so now we come on to question 18, and here we have a rectangle with a given length, a given width. This is in terms of x. We are told that here, the region inside the rectangle, outside the circle, so that's the shaded parts, has a total area of 20 centimeters squared. And then I'm asked to work out the perimeter of the rectangle. So I think I'm going to have to work out what x is most likely. Let's form a formula for the area of the shaded parts. So the shaded parts is going to be the area of the rectangle. So 4x times 2x, which is 8x squared, minus the areas of the circles. So we have two circles. Each of these is going to have an area of pi r squared. Well, the radius of each circle is actually going to be from here to here. And so each one, we're told as well, here is a radius of x. This is pi x squared. So I'm going to take the area of the rectangle and I'm going to subtract each of these circles. There's two of them. So we need to minus 2 pi x squared. And that is all equal to 20. Now to solve this equation, it's actually not too tricky when you notice that 8 and 2 pi are just numbers. So what I can actually first do is factorize out x squared from both. So I have 8 minus 2 pi times x squared is equal to 20. Now 8 minus 2 pi is just a number. So I can say that x squared is going to be 20 divided by 8 minus 2 pi. And that whole thing can just be typed into your calculator and you will get 11.649. Now this is x squared, not x. So what I'm actually going to do is take the square root to work out what x is. And the square root of 11.649 is 3.413. This is the value for x, but actually we were asked to work out the perimeter of the rectangle. The perimeter is all the way around the edge. So we have 4x plus 4x, that's 8x, plus 2x, so that's 10x, plus another 2x, that's going to be a total of 12x. So we have 12x as being the perimeter. The x, remember, is 3.413. So to finish off, to work out the perimeter, I'm just going to multiply 3.413 by 12. And you get a final answer of 40.956. Now we need to be careful here because we were asked to round to 3 significant figures. So this here is the third significant figure. So we have 40.9. So we look at the next number along here, which is a 5. This 5 means that we need to round this 9 up. We actually can't go up any further than 9, so it's going to be rounded to 10, which means that this 0 here becomes a 1. So this is actually 41 to 3 significant figures. Okay, moving on to question 19. So we're asked to work out the angle that BE makes with the plane ABCD. The plane ABCD is actually the base of this triangular prism. And then we want to know the angle that BE makes. I'm going to try and draw a line from B to E as neatly as I can. The angle that BE makes with the base. So it's actually, you need to go diagonally across the base. It's going to be this angle here that I want. So let's draw that triangle. I usually like to make these 3D problems into 2D problems before I solve. And so this is going to be B, this is D, and this is E. Well, what do we know about this triangle? All I know is that this is 2.2. That's all we have. So we're going to have to get the line across, or we could get the line across the top. So you're going to either go for EB or you're going to go for ED. I think I will go for, BE or BD. I think I will go for BD, the line across the bottom, the base of the triangle. And to get that, I'm going to use EDA. So if we look at this triangle here at the side, EDA, I know that this is 18, that's drawn in on the diagram, and I also know that this is 2.2. So we can actually work out the base DA, and to do that I'm going to use SOHCAHTOA. So this is a right angle triangle, the hypotenuse is over here EA, the adjacent next to the 18 is down here A, and then I have the opposite over here. So let's write out SOHCAHTOA. So I'm looking for the adjacent and I have the opposite. So I'm going to use this one here. And because I'm looking for adjacent, I'm going to say that the adjacent is equal to opposite over tan of angle. So opposite is 2.2 over tan of 18. I type that into my calculator and I can work out that the adjacent is 6.771. So that's this side here at the base, 6.771. Now once I've got that, that's here, I'm actually going to work out the line from D to B right across the centre, and I'm going to use the base of the shape. So if you imagine this is the 6.7 I've just worked out, this here is, so that doesn't make sense, I've got it the wrong way around. Like this. So this here is the base from A to D, and I've just worked out that that is 6.7. This is a right angle triangle. This is 6 because it's been given to me, and so now I can work out this side length here going right across the centre, and this is going to go from D to B, and so help us with this side here in a minute. This is just Pythagoras' theorem. So this is going to be the square root of 6 squared plus 6.7 squared. That will get us that length across the top, and that is going to be the square root of 81.85, which comes to 9.05. That's this, 9.05. And then I can also draw that 9.05 in here, 9.05. And that's this side here, 9.05. So we're very on the way now. I'm almost there. If I know this side is 2.2 and this side is 9.05, and I'm looking for this angle, again, I'm going to use SOHCAHTOA. Again, I'm in tangent. I'm going to write tangent of theta is equal to opposite over adjacent. This is the opposite. This is the adjacent. 2.2 over 9.05. And 2.2 divided by 9.05 is 0.243. This is tan of theta, not theta. So to get theta, you're going to use the inverse tan button of 0.243. And we end up with an angle of 13.7. To one decimal place, that's correct. Okay, moving on, we need to rewrite this quadratic in this form. So this is a completing the square. Now, I don't like that this x squared term is at the end. I want to put this at the front. This is how we would normally write these. When it's negative, sometimes they put it at the back, but I'd usually just rewrite it with the x squared first, and then the x, and then the number. Now, because of this number here, I need to factorize that out. I'm going to factorize out minus 2x, and I'm only going to do that from this first two terms. So I take minus 2 out of this term, I just have x squared. If I take minus 2 out of this term, that's going to be minus 6x, and the plus 7 remains alone. Now we're going to complete the square on the bit inside the square brackets. So this is minus 2, open up the square brackets, x minus 3 all squared. So I divide this number by 2, and then I'm going to subtract this number squared. This is minus 9. Close off the brackets, plus 7. Now we're going to expand out those square brackets. Let's get rid of them. So this is minus 2 x minus 3 all squared. Minus 2 times minus 9 is plus 18. And then the plus 7 on the end. And then we have minus 2 x minus 3 squared. And I'm just collecting together these two terms here. So plus 18 plus 7 is plus 25. Now, I think it actually, if you look at this problem here, it's got the number first and then the x and the minus c afterwards. So we could rewrite this way around. 25 minus 2 x minus 3 all squared. It's the same thing, but just puts it in this format that they were looking for. So in our case, we have 25 is A, 2 is B, and 3 is C. Like so. If you found that a little bit hard, I did do another video on completing the square, which I will link in the description as well. I do more examples like that, and they go a little bit slower as well. Right, let's look at the last couple of questions. So 21 here, this is an algebraic fraction. We're going to use normal bid maths, so I expect to do this bit in the brackets first. So I'm just going to focus in on this part here, and I'm noticing that I can factorize this. And I think if I factorize, I'm going to get something like this. Remember, we had difference of two squares, so if I have x squared minus y squared, why am I doing brackets? X squared minus y squared, this is going to be equal to x plus y, x minus y. And I'm going to use that again on this x squared minus 36. So this is 20 over x plus 6, x minus 6. And then I have minus 2 over x minus 6. Now I need to get them over a common denominator. So if I take this second fraction and multiply the top and the bottom by x plus 6, I will have the denominators being exactly the same. So let's do that. So we have 20 over x plus 6, x minus 6, minus 2 x plus 6 over x plus 6, x minus 6. And now you can see the denominator is the same on both fractions, so I can actually simplify this into one fraction because of the common denominator. So we have 20 minus 2x plus 6 all over x plus 6, x minus 6. Now we have a problem. That was only the bit done inside the brackets. I still need to multiply by this here. So actually in all of these cases, everything here needs to be multiplied by 1 over 4 minus x. Everything here needs to be multiplied by 1 over 4 minus x. So let's do that. I'm going to expand this bracket here now. So we have 20 minus 2x minus 12. Now this is all just being multiplied by 1, so it doesn't change. Over, I'm going to take this whole denominator here, x plus 6, x minus 6. And I need to times that by 4 minus x. And I think we're almost there. Let's simplify this down. So I can do 20 minus 12. We can just carry that out. So 20 minus 12 is 8. Minus 2x all over x plus 6, x minus 6, 4 minus x. And then now what we can actually do is factorize this. So do not stop here because I can see there's a 4 minus x hiding here because I can factorize 2 out the top. So let's divide by 2 and we have 4 minus x over x plus 6, x minus 6, 4 minus x. And now you can see that this is going to simplify with this. And so we are going to be left with 2 over x plus 6, x minus 6. You can write it like that, or you could have expanded those brackets. This is 2 over x squared minus 36, which arguably is probably the simpler of the two, but the mark scheme does allow either of those answers. Okay, this is a hard problem here, number 22. So here we have some surds to sort out. I want to rewrite all of this as 3 to the x. Now, because I want it as 3 to the x, what I'm looking for is hidden threes in all of these places. And so I can see that actually 27, this is 3 cubed. That's going to be key to me. And also 9, this is 3 squared. That's also going to be key. So the 27 and the 9, I'm both going to write as powers of 3. This 18, I'm seeing here, if I split 18 up into 3 times 6, it's actually going to cancel down with that 6 on the bottom. So let's do all of that now. So 18 is 3 times 6. I'll write it like this. And then I'm multiplying that by the square root of 27, which is 3 cubed. And then all of that is being raised to the power of 4n plus 6 all over. And then we have 6 times 9 is 3 squared, we've just said. And then that is all to the power of 2n plus 8. Okay, so now, as I said, this 6 will cancel with this 6. I'm going to rewrite this here as well. So if you have the square root of something squared, so cubed it is in this case, well, this is actually x to the power of a half. So we can rewrite this as x to the 3 over 2. These two things here are the same. So in this case, this is going to be 3 to the power of 3 over 2. So I have 3 times 3 to the power of 3 over 2 to the power of 4n plus 6 over, and then I have 3 squared to the power of 2n plus 8. Well, we can actually times these together. So when you have something to the power of something to the power of something, you can simplify this by multiplying these two things. So I'm actually going to do that. 2 times 2n plus 8, which you could have done it in one step, but in a moment we're going to expand those brackets. Let's do the same thing we did to the top as well. We did to the bottom to the top, so we can times these two things here together also. So I have 3 times 3 to the 3 over 2 multiplied by 4n plus 6 all over, and I can do that expansion now. So this is 4n plus 16. Okay, we're close. I'm going to do that expansion I did at the bottom on the top as well. So this is going to be 3 times, now 4 times 3 is 12, divided by 2 is 6, this is 6n, oh, no, 3 to the 6n. And then 3 times 6 is 18, divided by 2 is plus 9. And this is all over 3 to the 4n plus 16. Now, what's important to note here is that 3 is the same as 3 to the 1. And we're going to use this now, this 3 to the 1, and we're going to use rules of indices. If I've got the same base, 3 to the 1 times 3 to 6n plus 9, I can just add those two powers. So the numerator becomes 3 to the 6n plus 10. I'm just going to do this plus this. And 1 plus 6n plus 9 is 6n plus 10. And then this is over 3, 4n plus 16. And we're very almost there, because again, laws of indices, we can now subtract these two powers. So 6n minus 4n is 2n, and 10 minus 16 is negative 6. And this is my answer. So this is x. Remember, we wanted to write this. It asks us to show that we could write it as 3 to the x, express x in terms of n. So x is actually 2n minus 6. Okay, and this is the last problem in the exam. We have a kite. AB is equal to AD and CB is equal to CD. So this is kind of telling us the setup of the kite, and I'd recommend to draw some kind of sketch. So I'm going to label this A, and I know that AB is equal to AD, so these must be down here. these two sides are the same length. And then I also know that CB is equal to CD, so I can put C down there. These two sides are the same length in the kite. Okay, so point B has the coordinates K1, where K is a negative integer, and then negative constant, sorry. And then we have the point D as having the coordinates 8, 7. The straight line L passes through the points B and D and has a gradient of 3/5. So this is the line L. And I know the gradient of this line also. Find the equation of AC. So that's this line there that we're looking for, and write it in this given form. So the key thing here to note, and this is one of the properties of the kite, is when you join the two opposite vertices of the kite, like B and D, and join up A and C as well, those diagonals actually are perpendicular to each other. So we're going to use this fact. I can see that I got the gradient, and I think it's going to be important that they're perpendicular to work out the equation of the line AC. Also, this point here is going to be the midpoint. This is going to cross through the midpoint of BD on the kite. Now, what I need to do is work out what this K value is. I need that because I need the coordinates of that midpoint. And to get that, we're going to use the fact that the gradient of BD is equal to 3/5. Now, the formula for the gradient is the change in y divided by change in x. So the change in y is going to be the second y coordinate 7 minus the first y coordinate 1. This is change in y. Over change in x, which is going to be the x coordinates 8 minus k. So I have 7 minus 1, which is 6, over 8 minus k is equal to 3/5. Now we're trying to solve this equation now for k. We could multiply up by 8 minus k, multiply up by 5, solve like that. Or I'm noticing actually that if I take this fraction and multiply the top by 2 and the bottom by 2, I'll have 6 over 8 minus k is equal to 6/10. So I've just changed the fraction there, just scaled it up a little bit. And now the numerators match, so the denominators must also match. So I have 8 minus k is 10. So therefore 8 is going to be 10 plus k, or k is 8 minus 10, which is -2, which matches with the fact that it was a negative constant here. So this is now -2. So now I've got that, I can work out that the midpoint of this here is going to be halfway between the two x coordinates. So this is going to be -2 plus 8 divided by 2, take the mean, and halfway between the y coordinates, so 1 plus 7 divided by 2, also take the mean. And so -2 plus 8 is 6, divided by 2 is 3. 1 plus 7 is 8, divided by 2 is 4. So this is this coordinate here. I'll call that M, the midpoint. M is going to be 3, 4. So now I'm working out the equation of the line AC. Now I know the gradient because we know that it's perpendicular to this gradient. So if the gradient between B and D is 3/5, the gradient of AC, we're going to change that to a minus, change the sign, so it's going to be minus, and we flip the fraction, -5/3. So the gradient is -5/3, and the midpoint I have, so the equation of a straight line is y is mx plus c. And remember I just said that gradient is -5/3. So I have y is equal to -5/3x plus c. And I know it goes through this point here. So if I substitute this in for x and this in for y, so y is 4 and x is 3, then I can solve to get the c value and I'll have the equation of the line. So this is 4 is, these will cancel, so 4 is -5, where should I go? Let's go up here. 4 is -5 plus c, and so therefore c is going to be 4 plus 5, which is 9. So the equation of the line is y is -5/3x plus 9. But we have troubles because if you look back at the question, it asks it in this specific format. So we've done the equation of the straight line, but I want it written like this. P, Q, and R are integers. So they're integers, so I want no fractions, and I want all the x and all the y on the left-hand side. So because of this 3, let's get rid of that and times everything up by 3. So I have 3y is equal to minus 5x plus 27. And then I'm also going to take this negative 5x onto the left-hand side. So I have 5x plus 3y is equal to 27. And we have completed the entire paper. Thank you very much if you stuck with me all the way through that. I hope it was really helpful. If it was, then please like the video, and it will help more students such as yourself to find this video so that they can also check out the worked solutions to this paper. And as I said before, this is the only sample paper we have at this time for the course. I have created some which I based off the topics which come up in this course, and I've linked the PDF completely for free down in the description, so you can download that and have a go at another paper. Have a great day.